Okay, friends, let's get some solutions to this homework about financial math. Part the first. Okay, so the first thing we have to do is we have a 4% annual interest rate. We're going 10 years, and we're going to deposit 5,000 bucks in year zero. Okay, I think we can do this. And then we're going to make a graph too if you want. So we're going to have years here, and then we're going to have amount in account here. Try to spell amount correctly. All right, center that, center the whole thing actually. All right, so we're going to go from year 0, 1, 2. I'll drag that down to 10. Now you got a choice on how to do this next bit, this next formula to get the amount. 5,000 bucks is 5,000 bucks. We're going to start that just like that. This formula in cell F5, my F5, you might have a different one. I think the one that most people are using, and it's totally fine to do this, is this one. They're going equals that previous number times 1.04. And what that does is it takes 104% of the previous amount, which means you're bringing forward your 5,000 bucks and adding an additional 4% onto it. And then you can just drag that puppy dog down and you end up with about $7,400. There are other ways to use the formula. Some folks actually did it by taking F4 plus 4% of F4 and then drag that down. You'll notice it's exactly the same. It has to be. It has to be exactly the same because 1.04 is the same as 1 plus 0.04. So, and then some of you opted for the third variant of this, which was 5,000 times 1.04 to the number of years power. And again, exactly the same thing, which we discussed in the videos. This will also help answer the extra credit. If you use this form, it'll also help answer the extra credit as to why if you drag the formula up, this also works in year 0. I'll leave that as an exercise to you if you're interested. Well-labeled graph, I think you can handle that. Actually, everybody that turned this in did handle that, so well done. How many years does it take until the 5,000 doubles to 10? All right, well, the way most of you solved it was by extending your graph down. I'll pull it down to, I guess, 20 or 22 years for starters. And then drag this puppy dog down, and it looks like it happens somewhere between 17 and 18 years, like 17 and a half years, somewhere in there. Somewhere in that neighborhood. That's what I was looking for. The longer you let it sit, more money you got. All right. Complete the following sentence with one word. The dependent variable in a linear model is based on repeated additions. Additions. That's the point. You add the same thing each time, and that gets you your next value. Number 4, the dependent variable in an exponential model is based on repeated multiplications. Multiplications. That's the big difference between a linear model and an exponential model. What you do with the dependent variable to get the next, what you do with the independent variable to get the next dependent variable. And then this is that wonderful little formula that we ended up kind of establishing. We kept doing this over and over again. It was a pretty good look. What does the 1 refer to? We actually talked about this up here. It stands for the 100% of what was there previously being brought forward. The rate is the extra overage. The 1 is the part that was there before that we're adding to. Okay, pretty straightforward. Pretty much just a recap of the videos. Those were pretty intensive videos. A lot of Excel work, but you all did really, really well on this. So nice job. We'll see you soon.